Okay, in this second part of this lesson, we're going to talk about solving logarithmic equations. And really what you want to look for is these properties that you see here, focusing on kind of these three and seeing if you can apply any of those three, which you got some practice with before. So this would be an example of a logarithmic equation. You can see that it's a logarithmic equation because of the log in there. Okay, so now when I look back to this, I don't see any of these three properties here, number 2, 3, or 4, that I could apply. So it doesn't really look like I can do any of that, but some of the ones that we'll go through here later, you will be able to, and you'll see what that looks like. So I don't really have any simplifying I can do. So this is the stage when you're all the way simplified. So always check over here to see if you can simplify this logarithm. You might have a couple of them and see if you can do anything with that. And we don't here. So that means then at this stage you can try to convert it back into exponential function, which is why we did so much practicing with this before. This then is 6 to the third is equal to 2x minus 1. So then you would take your calculator and you would say, all right, what is 6 to the third? And that's 216. Okay, and then I would solve this equation right here, and now it's your logarithmic part of this equation is pretty much done. And this harkens back to your algebra days. So, and then we would take 217 divided by 2 on both sides. So here you can see we get 108.5 if we do that. Okay, so we just solved our first logarithmic equation. So that's one of the more basic ones where you don't have to do anything beforehand. Okay, so let's take a look at some different ones. Again, kind of keeping these three properties, or these four, but mostly the bottom three in mind. So, all right, so here you can see this says log base 4 of 100x minus log base 4 of 5 equals 3. And you'll see two logs, they both have the same base of 4 and a subtraction sign. So that's a pretty good indicator that we're going to be using this property right here. Okay, so I can rewrite this. Let's try it here. Log base 4 of 100x divided by 5. Since we have a subtraction in between, remember the property up top then says that we can end up dividing these two things. So I get this. So now I still need to simplify this 100x divided by 5. So that would be log base 4 of 20x equals 3. 100x divided by 5 is 20x. Okay, so now I want to look, and it doesn't look like I can simplify anything else. I don't have any other properties. There's no exponent right here or anything like that. So I don't have anything else to do. So now this is when you want to then do the conversion. Convert it back to an exponential function. So I would say 4 to the third power equals 20x. And then I want to take my calculator. Let's pull that up. 4 to the third is 64. So we would say, all right, 64 equals 20x. And then you're going to divide by 20 on both sides. So again, you've got that. Now you're going to just type that in. What is 64 divided by 20? And we get 3.2. So this is 3.2. Okay, so that means we have found x for a logarithmic equation. All right, so let's try one more that's a little weird. Again, keeping these three properties at the bottom in mind. All right, so here I have log base 5 of x to the fourth power equals 8. So again, I notice a little bit, it looks like this right here right now. So then I'm going to use this property to convert it and make it look like that. Okay, so let's try a different color here. Okay, so I'm going to move this 4 in front, like the property says. Okay, now again, still this logarithm is not isolated, so before I convert to exponential form, I want to get that by itself. So in order to do that, I actually need to get rid of that 4. Well, it's 4 times log base 5 of x, so we're going to do the opposite. We're going to divide by 4, divide by 4. So now these cancel, and I have log base 5 of x equals 2. Okay, so now that that logarithm is all by itself, now I can use conversion to exponential form. So I would say 5 to the second power equals x, and we know that 5 to the second power is 25, and there's my answer. And now I've just solved another logarithmic equation. So keeping in mind, just using these properties right here, we went through one with a minus sign in it and one that looks like this. But if you have a plus, then you're just going to multiply these two things here, that and that get multiplied. So using one of those properties to simplify before you solve the logarithmic equation. So hopefully that makes some sense, and you can use this to help you do your assignment.